On number 4, we need to find the length of a parametric curve. So our parametric curve is given by x equals e to the t minus t, and y is equal to 4 e to the t over 2. And we know that our t is in the range -8 to 3. So we just need to give the integral that would give us the arc length of this, or the length of this curve. So recall that the formula for the arc length of a given parametric curve is that you have from a to b, and those are the values of t that the function begins and ends at. And you take the square root of dx dt squared plus dy dt squared dt. So we have functions for x of t and y of t, so taking those derivatives should be relatively simple, and then we can just plug it into the formula. So dx dt is the derivative of this right here, and we would get e to the t minus 1. dy dt is the derivative of y here, so we'd have to bring half down from the power, but otherwise you would leave it the power the same, and we get 2e to the t over 2. So we have dx dt and dy dt, so we're going to be taking the integral, and we know this is going to be from -8 to 3 because of the range of t's we were given. So we would have square root of dx dt squared, so we have e to the t minus 1 squared, plus dy dt squared. So when we square this, we can just square each term because these are multiplied, so we would get 4e to the t. And this is something that we could actually simplify. So in the radical there, if we expanded this e to the t minus 1 squared, we would get e to the 2t, so we get minus 2e to the t plus 1, and we still have this plus 4e to the t dt. So you can see this actually is going to work out nicely, because if e to the 2t minus 2e to the t plus 1 is this quantity squared, when we combine -2e to the t and 4, we're going to get positive 2. And that's the same factorization if this sign was positive here. So we know that this is square root of e to the t plus 1 squared. And you can see there that if we take the square root of something squared, we just get itself. So all we need actually is e to the t plus 1, and we're evaluating that from -8 to 3. So evaluating that integral would give you the length of that parametric curve.